So everything seems fine for now. Let's start with defining some roughness values for the object. I will copy the roughness value of the frame from the monitor substance. Let's copy the roughness blendings. And paste it to our new graph. And we have panel color blended with the outer frame. So before renaming it, the inner frame also should be a roughness value. Let's copy it and add a frame for this. For the panel, I will add a blend node for this and blend the panel with this by using this opacity map. And let's create the panel in a metallic way with a low roughness. And then for the inner frame, I will copy the inner frame mask, which is high on some roughness values. Next, we will be having keypad back panel. Let's remove this unnecessary roughness levels because they will not be repeated in our new object. We will be copying the roughness values for these colors. Let's copy those and move it here. For the keypad back panel, I will convert these colors to grayscale first, which we will be using as independent roughness values for each blending. Keypad back panel roughness is set. Now it's time for the screen. Alright. And for the buttons, finally, I will be using the same mask for the bottom frames. Yes. Let's expand the base color blending frame because we have some additional blendings here. Our graph getting complicated. Let's add a frame for the LED light. Colors. Okay, now we are continuing to create roughness blendings. Now we will be using another roughness values, for one for LED lights and one for the LED light frames. I will create a copy of these nodes and rename those as LED and LED frames. Now I will be connecting these to the blending of the roughness, and for the frames I'm adding this, and for the final LED light roughnesses I will use the unmasked ones, which is the LEDs with those two are active. So let's connect these to the roughness channel. Let's check the screen, because its bump doesn't look good. I will check the final height. And also we can increase the normal map intensity to get a better normal map feel. But for the screen we may need to exaggerate the bumpiness of the normal map individually. Let's add a blend node and let me find the state that we added our screen. I will use the screen mask for the blending, and also I will use this bright screen bumpiness instead of this lower value screen. By this way it will not affect the height, but our normal map will be generated by this intense level of screen bumpiness. So let's check the screen roughness value. I will drop it down to see the reflection. You can see that it's much more bumpy than the usual. Let me show you the previous one. If I remove this, if I connect the old height map value to this normal map, check the screen on the 3D view. It will be less bumpiness, but this way, when I connect the exaggerated height level to the normal map, this way we have a much more bumpy screen, which is better. Also for LEDs I will lower the roughness values. And also we need to check the bumpiness of the green value. And for the frames I will increase the roughness a little bit. And let me check the height levels, height blendings of these LEDs. We used add, and we have the same values, but I suppose we have, oh no, their bumpiness are looking good. I was wrong, I suppose. Yeah, there's no problem on that. All right. Yeah, that's much better. And for the metallic values, I will just create a copy of the roughness blendings and change the values to create a good metallic blending. I will move the outputs to this area, create a copy and pass the roughness blendings. I will rename it as metallic blendings. And I'm temporarily connected to the metallic channel. Let me check the metallic levels. Outer frame should have no metallic value. Panel should be metallic. Inner frame may have some bronze look, which is cool. Keypad back panel is looking fine with low metallic values. Screen should not have any metallic value because it will be not so realistic. For the buttons, I plan to use very metallic result. And also we need to lower the roughness of the buttons. All right. Button frames should be fully metallic. Maybe not so fully, but no, maybe the plastic look would be better with a black color. Right. Let's increase the roughness of this button frames a little bit. All right. LED frames are plastic. LED itself is plastic too. Button frames are set and good. Now we can continue to create some brushed metal look on the metallic parts. We will make this effect on the normal map channel. So I will add a blend node to normal channel. For best and fast brush metal look, anisotropic noise is a cool way to create that effect. Let's start with this. For now, I will use a subtract from the rest of the objects, but I will use a mask to be subtracted from the anisotropic noise to get a brushed feel. First, I will blend the back panel mask with the bottom mask. To create that mask, I will use several blend nodes. I will take the buttons mask and I will subtract the button frames from this set by setting the blending mode as subtract, and then I will take the panel mask and subtract almost everything from that panel. But since we have created some different roughness values, maybe it will be easier to just use some metallic, get the metallic channel with extracting the high values from the metallic channel to get that mask. Let's try it. I will use an histogram select node and connect the metallic result to my histogram select node. So with a very low range, I will just try to find the exact value for the panel. And maybe let's check the buttons first. There are some color changes on this. Alright, I will just add a blend node to subtract the keypad panel first. Because there are some messy results from the key channels. So this will be much clearer now. So this way it will be easier to extract the panel mask. I will set the range in a very low value. Let me check if I remove this. Okay, we have some artifacts here, but it's not so important. So I will use this as a brushed metal mask. And by the way, I will add a blend node to combine this with the buttons by using the max lighten option, so that the artifacts here will be overridden by the keypad values. So it's totally okay. Now I can tile the anisotropic noise texture to get a better seamless result for our blending brush metal feeling. So by the way, I need to change the tiling mode for this particular node. I will set it to absolute and H and W tiling. Now I realize that anisotropic noise doesn't have a tileable option. After decreasing some top white level values, our metallic look became better than the first one. Also, let's remove the normal map manipulation and just leave the roughness effect of this anisotropic noise, which looks also cool, by the way, but I just want a little normal map effect on the shape. Alright, now we have the metallic look on the back panel. Now we can create the numeric values over the buttons. To do that, we will also create manipulation on the normal map channel, because we don't need a specific deformation on the buttons. Even we want to have a carved numbers here, there is no need to use a height map manipulation. So let's start with creating the numbers first. For that, I will use text node and put numbers over the buttons. To do that, I will just need a reference for the phone dialers. Let's search for it. I made a search about the phone dialer, and we can take this as a reference for the letter inputs and the numerical inputs. This covers the 3x4 matrix of our button system. We will add additional details to the right column of our numeric pad. Let's start with the numbers, which we will be using the standard numbering with text. Before adding the text, we need to make the alignment first. It's already in the center, which is good for us. And because if we add additional data, the total input will be centered on the canvas. So this will be the first number. We can change our text font by this area to get a more futuristic look on our numbers. I have an font for better for this kind of needs, which is named Infinium Guardian. Let's try to add the other numbers by this way. I will just copy and paste several times to create the copy of this text node. We may also use these numbers by putting space between them, by making less usage of nodes, but it's better to adjust them independently, so our control will be better and placement will be better for these inputs. So let's change the numbering here. I will select and add the number we want. Okay. Since these nodes doesn't connected to the output nodes, they are not calculated first, but when you double click on them, you will see the resulted look on the screen. So we have 0 here, and we have the star and the dash. Dash looks good, but star doesn't look great with this font. I will change the font for this. Let me check if any similar looking font here. Alright, this will be okay for our need. Now we have our text metrics, then we need to place them on besides of themselves by creating a tile sampler node. Tile sampler node allows us to use multiple patterns by input. Let me check if we can use more than 6. No, it's not possible. Let me check for the tile generator. Okay, these generators doesn't allow us to input more than 6 values. So let's start with putting the first 6, and then we will align the rest. You can see that it generates randomly placed inputs. Let's start with changing the pattern distribution first. And also we have some shift on numbering. All right. Okay. For the image input, we need to change the pattern input distribution mode from random by the pattern input number. You can see that it makes the pattern input by adding them between the columns 1, 2, and 3, 4. So we can change the order by changing our positions for this distribution. Like we want to use the 2 on 3's position. We change the positioning like this. And also for the 3, we just move the input by the desired position. For the 4, we need to use the 2. And also for the 5, we need to use 4 and 6 in the position. Now we have the distribution of our images. So we can change the scaling and additional distances between the objects by this tile generator. So yeah, it's tile generator. Then let's start by changing the Y amount to 4, and then we will use a mask to change the distribution, but since we are using a tile generator, we can't use masks. So let's start with adding a shape, and we will change the size of the Y to 0.5, and then we will use a transformation 2D node to move the white area by 0.25 to make a splitted rectangle, and then we can multiply this one. Let's change the moving this to the upwards, and we can multiply this with the white area to mask the rest of the bottom part. Now we can create a copy of the actual generator, but first let's align the other texts with this tile generator. Then we can create a copy of this tile generator and connect the rest of the numerical values to that one. Let's create a copy of the first 6 for the additional letters on the numbers. Let's start by this part. There is no lowercase for this font, which is okay. For that, we need to do the placement first. Let's delete this. I will decrease the font size, and then I will blend this with the number 1 by using the max lighten blend option, and then I will use a placement for this letters. Let's connect 2 because ABC is on the number 2. Then I will move it a little to the bottom, and by the shift key I will change the output to this blending. Let's check how it looks on the shape. It's okay, there is no intersection by this addition of the letters, so we can use this placement by changing the letters and blending with the other numbers and connect them to the tile generator to finalize the button placement. So this is for 2. Let's create a copy and change the letters to DEF. Make the connection with the 3, and by the shift key I will change the distribution of the letters to the 3. Still we have some wrong positioning. Let's correct this. All right. Okay. I'm checking the reference, by the way. Okay. Now we are also wrong numbering on the 5 and 6. I will tidy up the graph a little bit. Let's remove those, and so we can create a copy afterwards. All right, let's use this clean area, and now we will just create a copy and then change the numbering again. Let's check the result because we have made it wrong again. 7 is 8. It is 9. And the 9 is 7. This can't be get more confusing here. Zero, but our font is changed. Okay, now we can change the 5 as 0. And 6 should be the star. Okay. And we use the dash by here. Don't mind the top part because we will mask it. Alright, just we need something for the 8. And check the reference again. We have no lettering on the bottom part, so we will just use letters for the 7, 8, and 9. I will create a copy of these. Okay, then we can remove the unnecessary blending for the rest of the numbers. Let's invert this. And now we have the correct letters. Now we can blend these together by using the max lighten option. And now we have the correct layout for our numbers except the lettering. So check the 8, 7. Okay. Now we need to make the placement of these numbers exactly as the same of these buttons. As you may remember, we made a tile just like this for our buttons, and then we used these two transformation 2D nodes to make the placement for these buttons. So I will copy these two and paste it here. When I connect the numbers to them, our placement will be exactly same with these buttons. Then we can use subtraction for the normal map to create a carving of these texts. I will add a blend node and use subtract function and connect the numbers with the rest of the shape. Didn't comply as we thought. Let's check the nodes again. This transformation 2D node places the number buttons here. Let's check by double clicking to the final result. Buttons are in their position, but it's okay. We didn't use the 4x4 transformation for those. So it's normal that we have ended with this result. So we need to make manual transformation again in the scaling. Just like this. Now our subtraction works. And also we can decrease the subtraction opacity to get a better result. Also, we added fine details by normal map, so the ambient occlusion should be calculated not just by the height result, also with the normal map. So since our normal map, the height details before the normal map has much more detail, we may connect the result to the ambient occlusion node to get these additional details occluded by our node. Now you can see that we have some dirt and occluded areas between these numbers because they are carved inside, which is good. Let's start by finalizing the right panel buttons and complete the keycap texturing. All right. Let's frame this area. Okay. Brushed metal panel. We will not add this blending because this blending is just for adding the numbers to the buttons. Let's start with the additional texts. For them, I will be using video call. Let's use the same font. Voice call. End call. And mute. I will use tile generator again, this time 1 on X and 4 on Y. Tiling will be used. For the image input, I'm defining the input number as 4. Connecting all the text inputs. And for the input distribution, I will use the pattern input number. Now you can see that they just squeezed along to the horizontal edges. There are workarounds for this. At the size, you can change the middle. Let me check. You can change the interstices by aligning the aspect of this text, and then I will using the blend node with the same transformation 2D nodes by connecting my new texts to this transformation 2D nodes, and by the max I will be able to align the new buttons to their positions. Alright, the texts are too high for this blending, so in the tile generator I will scale down the texts. Let's move them a little bit to upper position. Alright. Now we have our final buttons for the right column. That is the screen and numerical pad for the electronic device that we are creating. And we forgot to add the camera for the video calls, by the way. Let's change the screen size a little bit to make a room for the camera here. I will just start a simple shape like hemisphere, and I have a good idea to manipulate this shape as a optical camera look by adding a curve, because the transition between the outer borders to the center makes us to be able to create some good deformation at the radially controlled way. So let's start with sharp corners. This is the flat edge. Gets to the center. Right. Let's move this to top to get room for the rest of the shapes, like this. And for this angular area, which corresponds to this angle, we can add additional levels to create a ring around this angular drop. Let's start by double clicking to the areas and add some points, and I will change them to shape corners. And then I will create a ladder shape for those to make some steps on this angular drop here. So in the center, I will ramp up again the value to get the glass lens of this camera. In the final shape, I will add a little blur to this height map, and then I will add two transformation 2D nodes to scale and place the shape to this area to see how it looks. Okay, that's the final blending of our height map. Let me check where it goes to the height channel. Oh, this is okay. This is the blending where we exaggerated the CRT bumpiness. CRT bump ramp up. So this is our final blending before the height map output channel. I will connect this to this area, but before that I will firstly place the camera here, but I will create some seams around the camera afterwards. Let's scale down the camera shape. I will double click to the height blending to see it on the 2D view. I will select the max light blending option and use these nodes to place the camera to desired position. Let's scale down a little bit to get better placement here. Alright. Now we can either adjust levels of this shape, or we can just change the opacity of this blending. I prefer to create a mask and copy this detail over the final height result, and then I will adjust the levels of this particular shape here. So let's start with adding a levels node to create a mask for this shape. For this I will add a distance node. Or let's try the edge detect node. Let's blur it a little. Then I will add another levels to push down all the values again and blend it with the previous shape by the max lighten option. Now I will just use this mask to subtract from the final result of our dial pad. Let's scale the edge of it a little bit down because it touches to the side parts. Okay. We need to drop down the blurring a little bit to get rid of this edge touching. Maybe we can change the screen positioning a little bit to the up. Let's add a transformation to the node here and move the screen to an upper position. Also, let's change the horizontal scale. Sorry. Let's do it from here. Okay, which is better. Now I will move the positioning of this camera. Right. Let's finally add another blur. It's hard to control this shape because it's too tiny for our resolution to make it smooth like here. But finally we managed to get it to somewhere. And now I will use the camera shape by copy using the same mask that we subtracted from the first shape as a mask. Alright. Now we can adjust the levels of our camera shape. I added a levels here. And now I can drop down the overall white values to bottom. And also it's better to just adjust the outer seam of this shape. We can do this by increasing the shape from the first transformation 2D node to get a better alignment with the rest of the object. Okay. The thing we have done here generates a higher scale of seams for this camera. Let me reduce it a little bit to get a better result. Okay. Now it's looking much better. And also we have our camera. Let's move it down a little bit more. Alright. Okay, now our camera affected from the metallic look that we have made with this back panel. So for the panel mask, we need to subtract our camera mask from this panel mask. I added a blur there and moved the mask that we have created for this blending to subtract from the object. Now the panel mask is like this, and we can add additional details like color for our camera. Let's make it by here. I will add a blend and a uniform color for the camera color. I will just use a single color for the camera, but for the roughness values I will create a variation for it. I just placed the wrong mask for that job. check. This is our camera and this is our roughness blending. We made a wrong connection here. Yeah. Okay. I'm just moving the mask input to the camera mask. By the way, we can create a frame for these shapes as the LED light mask extraction. Alright, and this is the part we made our camera. Change the typo here, right? Now we will add a roughness value for this camera. It has already some value here, but we will use the inside part of this camera, which makes the lens is low on roughness, and this frame over it will be high on roughness. To do that, I will just use a simple shape to mask it from the camera value, camera shape. So create a disk, lower the scale, add a blend and subtract from the, let's not use it. I will just use this blend for just the alignment and seeing how my shape scale should be. Then I will remove it. It's a temporary shape. Alright, now I have a mask for the lens. I will take it on the roughness blendings, put it here, and I will add a uniform color. It should be grayscale and low on roughness, and connect it. For the frame of this camera lens, I will use a blend and subtract the camera center from it, add levels and push down the values. I will copy the previous placement transformation 2D nodes, and this time let's add a blend of the roughness here. I will use this mask and a uniform color of grayscale with high roughness values, and move this to roughness blendings area, and connect the rest of the shape to that, and move the output to this area. So this roughness is very high, so I lower it a little bit to get a better result for the frame. Maybe we can increase the black level for the camera color, which looks better. All right. We almost made a 3D modeling through the 2D textures, and we have already textured this 3D model. In fact, the 90% of this textured. So we may add additional details on Substance Painter by moving this texture to the painter, because since the latest update, Substance Painter supports the displacement maps, so we can import these textures to our working area in Substance Painter by these height deformations, and also we will be able to add details by painting and brushes to this 3D shape. But before that, we need to complete the other side of the electronic device that we are modeling, which is the telephone handle on the left side.